Our next topic will be about the Bernoulli's equations. So just like the linear equation, Bernoulli's equation has also standard form, integrating factor, and a specific solution. But we are introduced here by a new variable v, which is equal to y to the exponent of 1 minus n. So the standard form of a Bernoulli's equation is dy over dx plus p of x times y is equal to q of x times y raised to n, where n must not be equal to 1 or 0. And so our integrating factor will be equal to e raised to the exponent of 1 minus n times the integral of p of x dx. And our solution is the variable v times the integrating factor is equal to 1 minus n, and the integral of q of x times the integrating factor again dx. So our examples, number 1, 2x cubed y prime is equal to y times y squared plus 3x squared. And so we are going to put the equation into standard form, that is y prime will be equal to dy over dx, and then dividing all terms by 2x cubed, and so the result will be dy over dx minus 3y over 2x, while transferring 3x squared y from right to left of our equation, equal to y cubed over 2x cubed. And so here we are able to identify the values of p of x and q of x, which is negative 3 over 2x, and q of x is equal to 1 over 2x cubed. And our n is 3. Our n is the exponent of our y here, etong term na kasama ng q of x. So next is we are going to solve for the values of integrating factor and v. So if is equal to e raised to 1 minus n times the integral of px dx. Substitute. So that is 1 minus 3 integral of negative 3 over 2x dx. And then the result, 1 minus 3 is negative 2. Transferring out the constant here under the integral sign, which is negative 3 halves, times the integral of dx over x. And then simplifying further, negative 2 times negative 3 halves is equal to positive 3 times ln of x, raising 3 to the exponent of x. And so our if is equal to x cubed. And for v, that is y raised to 1 minus n, y raised to 1 minus 3. And so our v is equal to y raised to negative 2. And then substitute all the values in our solution. So our v is y raised to negative 2. Our if is x cubed, equal to 1 minus 3, our n, times the integral of 1 over 2x cubed, our q of x, and then if is x cubed times dx. Simplifying, that is x cubed y raised to negative 2. 1 minus 3 will result to negative 2, and this one will be cancelled. X cubed will be cancelled, so 1 half dx will be the remaining value under the integral sign. And transferring out 1 half under the integral sign, so that will be equal to negative x plus c. And simplifying, making the exponent of y to positive, so you have to multiply both sides of the equation by y squared. So that is x cubed is equal to y squared times c minus x, our differential equation. Next example, that is the quantity of x raised to 5 minus y squared times dx plus 2xy dy is equal to 0. First step is to put the equation into standard form. And so we have to divide all terms by 2xy. So that is the quantity of x raised to the 5th minus y squared all over 2xy plus dy over dx. And then separating the two terms here, the x raised to the 5th and the y squared. So that will be plus x raised to the 4th power over 2y minus y over 2x. Moving the term x to the power of 4 over 2y from left to right of our equation in order to identify the values of p of x and q of x. And so our p of x is negative 1 over 2x. Our q of x is negative x raised to 4 over 2. And then our n is negative 1 since our y variable together with the q of x is on the denominator. So that has the exponent of negative 1. And the next step is to solve for the values of the integrating factor and the v. So if is equal to e raised to 1 minus negative 1 times the integral of negative 1 over 2x dx. And then simplifying, transferring out the constant negative 1/2 from the integral sign. And so the result will be negative ln of x. And then raising negative 1 to the exponent of x, so our integrating factor will be x raised to negative 1. Then our v is 1 minus negative 1, so that is y squared. And so substituting to our solution, the y squared times x raised to negative 1 is equal to 1 minus negative 1 times integral of negative x raised to the 4th over 2 times x raised to negative 1 dx. Then simplifying, 1 minus negative 1 is equal to 2, and then x raised to 4 times x raised to negative 1 is equal to negative x cubed. Transferring out negative 1/2 outside our integral sign, so 2 times negative 1/2. So that is negative 1. And then integrating x cubed dx, that is x to the 4th over 4. And then since x here is raised to negative 1, so our y, so this term will be equal to y squared over x. And then simplifying further, we have to multiply 4x to our equation in order to not have any denominator. So that is 4y squared plus x raised to 5 is equal to cx, our differential equation. Next example, the quantity of x squared plus 6y squared times dx minus 4xy dy is equal to 0. First step again is to put the equation into standard form. So we have to divide all terms by 4xy dx by 4xy dx. And then separating these two terms on our numerator, that will be negative x over 4y minus 3y over 2x is equal to 0. And then transferring this term from left to right in order to find for the value of q of x. So our p of x is negative 3 over 2x, and our q of x is x over 4. And then our n again is negative 1. And then next step is to solve for the values of integrating factor and v. So that is e raised to 1 minus negative 1 times the integral of negative 3 over 2x dx. And then transferring out the constant under the integral sign and then simplifying further, that is negative 3 ln of x, raising negative 3 to exponent, that is x raised to negative 3, our integrating factor. And then solving for v, that is y raised to 1 minus negative 1 or y squared. And then using the solution, y squared times x raised to negative 3 is equal to 1 minus negative 1 times the integral of x over 4 times x raised to negative 3 dx. Simplifying, that is 2 the integral of x raised to negative 2 over 4 times dx. And then our constant will be equal to 1/2 since we have transferred 1/4 from the inside to outside of our integral sign. And then integrating the x raised to negative 2 dx, that will be equal to negative 1 over x. This term will become negative 1 over 2x, while on the left side of our equation, making the exponents positive, so that is y squared over x cubed. Simplifying further, we have to multiply 2x cubed to our equation. So that is 2y squared plus x squared is equal to cx cubed, our general solution. And then, when x is equal to 1 and y is equal to 1, substitute the values of x and y. And so we found that c is equal to 3. Substituting the value of c to our general solution, that will be 2y squared plus x squared is equal to 3x cubed. And then factoring out x squared to the common terms, that will be equal to 2y squared is equal to x squared times the quantity of 3x minus 1, our particular solution. That ends our lesson about Bernoulli's equation. For our next topic will be all about the applications on first order differential equation. For your questions about Bernoulli's equations, comment down.